The technology in design and technology comprises of electronics, mechanisms, and structures. In Secondary 1, you will learn about electronics. Electronics are all around us. They play a crucial role in our daily lives. They are usually hidden inside nice covers so we do not actually see them. What happens if there is no electricity in our light or LED bulbs to bright dark places? What happens if there is no electricity in the fans to blow us when we are hot? What happens if there are no electrical or electronic components in our computers? Many products these days rely on electronics. By the end of the lesson, you should be able to differentiate between an open-loop system and a closed-loop system. Differentiate between conductor, insulator, and semiconductor. Differentiate 2 types of power sources. Differentiate 9 different types of switches. Identify 4 types of output sources. Understand the use of resistors. And construct series and parallel circuits. There are 2 electronic systems, open-loop system and closed-loop system. In open-loop system, it comprises of an input that is processed and becomes the output. The input is gathering of information. The process is the electronics that uses the information and performs a function as the output. For example, you press on the light switch. This is the input. The electrical circuit is closed for the electricity to flow through. This is the process. The output is the light shining from the bulb. Let us use a calculator as another example. The input is pressing the buttons on the calculator. The calculator has electronics that processes what is being pressed. The output is the number or calculated number that gets displayed on the calculator screen. In a closed-loop system, a feedback is included to the open-loop system. This makes the product smarter because it can control or adjust the system automatically. A closed-loop system can respond to the changes based on the output information. Sensors are commonly used for feedback. For example, motion-controlled sensors detect a person entering the toilet. The lights automatically turns on. When the person leaves, the lights go off. This is an example of a closed-loop system. An air conditioning system also uses a closed-loop system. Say the room temperature is 32 degrees Celsius. It is very hot and you decide to turn on and adjust the air conditioner to 25 degrees Celsius on the remote control, which is the input. As the air conditioner cools the room temperature, which is the output, drops lower. The sensor provides the feedback that the room temperature is still not 25 degrees Celsius and the air conditioner processes the information and continues to cool further. Once the room temperature reaches 25 degrees Celsius viaduct the feedback through the sensor, the air conditioner maintains at 25 degrees Celsius and does not go below that temperature. Let us look at the classification of materials. They are conductors, insulators, and semiconductors. Conductors are materials that allow electricity to flow through them easily. Most metals are electrical conductors. Gold, silver, and copper conduct electricity readily, so they are found inside wires. Water is a good electrical conductor too. Insulators are materials that do not allow electricity to flow through easily. Examples include plastic, rubber, stone, glass, wood, and so on. A combination of conductors and insulators are used together. For an light switch, the casing is made of an insulator to protect anyone safely from being electrocuted by the electrical conductor when current is moving actively. Semiconductors are special materials that allow electricity to flow through, but not as easily as metals. Materials include silicon and germanium. These are commonly used in computer CPU chips, LED, and solar panels. Where does electricity come from? Usually we also call electricity power. 2 main sources of power are mains power and battery power. In mains power, the electricity is very high and comes from the power substations. Mains power supply alternating current, also known as AC. Since it comes from the substation, the electricity supplied is very stable and can travel long distances. However, most home appliances use direct current or DC as electricity, so the AC needs to be converted to DC before the appliance can be used. For example, the computer requires a small black AC adapter to convert the electricity from AC to DC. The battery power produces direct current and can be used instantly on most home appliances. Batteries are portable, but they are limited in capacity. Some examples are computer batteries, phone batteries, AA batteries, and power banks. Since they wear out, the difficulty to dispose them also becomes an environmental concern. Electronic components need to be joined together so that they form a circuit for it to work. For the ease of drawing circuits, electronic components are drawn as circuit symbols. The common symbols here are the cell, battery, and the bulb. People mistakenly call a cell a battery. Actually, one in itself is called a cell. A battery is a series of 2 or more cells connected together. Light switches are used for opening or closing a circuit. Opening a circuit means breaking the circuit so the current does not flow through. Closing a circuit means making a circuit so that the current can flow through and the appliance works. The switches here could refer to the input of the open or closed loop systems. As you can see here, there are different types of switches. They are the rocker switch, slide switch, push switch, toggle switch, press switch, micro switch, reed switch, tilt switch and the more complicated membrane panel switch. They are chosen for the product based on design and function. A rocker switch rocks on and off. Here are some examples of a rocker switch: a printer, a kettle, light switch and lamp switch. If you observe the appliances around you carefully, they are actually very common. A slide switch simply slides on and off to close or open circuit. Examples of appliances that use a slide switch include a portable fan, a bubble toy gun, a shaver and a wireless mouse. This type of switch is also very common, so look around and observe carefully. Toggle switch uses a lever to turn on and off an appliance. A lever is like a long bar or rod as shown in the photos. They are mostly used in workshop machines and in the cockpit of an aircraft. 12A press switch has a spring inside it to momentarily switch on and off a circuit. When you press the press switch, it turns on the circuit. Once you release the switch, it will spring back and the circuit will be turned off. Examples include the keys on a calculator or keyboard, as well as a doorbell. A push switch is different from a press switch. Push and press sound similar, don't they? A push switch, however, stays in position even when you release it. You need to press it again to release it. Examples shown in the photos include a portable fan, car keyless ignition and a computer monitor power button. Are you able to think of more appliances that use a push switch? Micro switches are commonly found in cooking appliances such as microwave ovens, rice cookers and air fryers. They are usually discreet, but they act as safety devices to turn off the power. If you accidentally open the door of the cooking appliance to check your food while it is still cooking, the micro switch will turn off the heating immediately as a safety precaution. You would not want to cook your fingers, don't you?
A microswitch works by using a spring-loaded lever to open and close a set of internal contacts. Power is typically attached to the common terminal. This leads into the switch and energizes the spring, and because the spring is touching the normally closed pin, sends power out here. This is called the resting state, meaning there's nothing pushing against the activating arm. The moment the arm is moved, the spring snaps into a new position and changes the path of power by sending it out the normally open pin.
A reed switch has two separate metal contact strips inside. When a magnet is brought near the reed switch, one of the metal strips is attracted to the other, and connects the circuit to allow current to flow through. When the magnet is removed, the metal strips separate again to cut off the power in the circuit. The reed switch is commonly found in door alarms. It is also found in laptop computers. When the screen is closed downwards, the display on the screen automatically goes to sleep mode.
Take my magnet and pass it by the switch. The contacts close. You can hear the beeping sound indicating that the two contacts have been pulled together. They close to make a complete circuit.
A tilt switch has a mercury blob or metal ball inside. By tilting the switch, the blob or ball rolls to connect or disconnect the two metal contacts inside. When connected, it forms a closed circuit and current flows through. The tilt switch is commonly found in controlling the flight of an airplane or game controller. The membrane panel switch has at least 3 layers with the copper layers facing each other in the inner layers. When a panel is pressed, the copper layer at that location presses down and touches the copper layer, thereby closing a circuit to perform a function. Common applications include a washing machine control panel, a hot water pot control panel, a microwave oven control panel and the cash register panel. The output components here perform different types of functions after the electricity goes through the process in the open or closed-loop system. We will be covering a few basic output components such as bulb, LED, buzzer, and motor. The bulb or lamp converts electrical energy to light and heat energy. They are used in table lamps, projector lamps, old signboards, and old car headlamps. The light-emitting diode or LED for short converts electrical energy to light energy. It is more energy efficient and does not produce heat. These are replacing light bulbs very quickly over time. Common applications of LEDs are car headlights, traffic lights, digital clocks, decorative light strips and torch lights.
LEDs, light-emitting diodes, are everywhere. They come in a wide variety of colors and are found in places like automobile dashboards and clock radios. Many make-crate projects involve circuits that include LEDs. So let's take a look at how an LED works. A diode is an electrical component that only allows current to flow in one direction. In an LED, the longer leg is the anode or positive leg, and the shorter leg is the cathode or negative leg, and the electricity can only flow from anode to cathode. So if you put your LED in backward in a circuit, it won't light up. The components inside the LED have special properties that allow them to emit light. Electrical components fall into one of three categories: insulators, which don't allow electricity to flow through them; conductors, which allow for the free flow of electricity; and semiconductors, which fall somewhere in between.
LED has two leads, or contacts. The LED will light up only if the current enters the LED from the longer positive lead, known as anode, and out from the shorter negative lead, also known as cathode. If both legs are the same length, perhaps by accident, then the negative lead is identified as the one on the flatter side of the LED. The buzzer is also a common output component. It converts electrical energy to sound energy. It makes a noise depending on the sound frequency being set. Common applications are doorbell, alarm clock, electric fire alarm, toaster, refrigerator, or washing machine. A direct current motor converts electrical energy to kinetic energy. Kinetic energy is motion. Motors are found in fans, engines to rotate the wheels of cars, drones, and boat propellers. Output components allow a certain amount of current to pass through them to function properly. Excessive current can damage an output component. To protect the component from the high current, a resistor can be connected before it. A resistor limits the flow of current. Resistance is measured in ohms. A high resistance allows less current to flow through. A low resistance allows more current to flow through. The amount of resistance of a resistor can be determined by comparing the color bands with a color resistor chart. You do not need to know how to calculate the resistance at lower secondary level. The circuit diagrams show the switches arranged in series on the left and the switches arranged in parallel on the right. It features the input components. On the left, this type of series arrangement is usually used for safety purposes. Perhaps you need to turn on the switch of the mains power supply first, before you turn on the switch for your electrical appliance. On the right, the switches arranged in parallel could be at different locations. For example, if you are upstairs or downstairs, you can use either the switch upstairs or downstairs to turn on the stairs light. The circuit diagrams here show the bulbs arranged in series on the left and the bulbs arranged in parallel on the right. It features the output components. When the bulbs are arranged in series, the circuit becomes open when one of the bulb is blown. The current cannot pass through the circuit. This means that the other bulb will not light up as well even though it may still be working. When the bulbs are arranged in parallel, the current flows through both branches. When one of the bulbs is blown, the other bulb is unaffected because current is still flowing through the other branch. This arrangement is commonly used in house lighting. That's all knowledge for the electronics component you need to know for you to answer the questions in your graded SLS quiz. All the best.